So most expected questions from signals and system. Before this, you can go through the current frame. Most expected questions for CSE will start from 12th of June for ISRO and NIELIT. This is the brief introduction about me. Students, I have been teaching in this domain since many years, and my subjects of interest are engineering maths, signals and system, and analog circuits. So, here comes our first question. So, students, if we have a function f of t which has the Fourier transform f of t is having Fourier transform g of omega, the Fourier transform g of t is okay. So, actually, this should be like this. F of t is having Fourier transform g of omega. Now, in this g of omega, what we are doing, we are putting omega equal to t. So, we are applying the duality theorem. So, it is 2 pi times, in this f of t, you have to put minus omega, 2 pi times f of minus omega. So, this is in accordance with the duality theorem. Can I have your response on this? So, 2 pi times f of minus omega, option C will be the correct answer. So, what is duality property? If f of t, or you say x of t, is having Fourier transform x of omega, and you are willing to calculate the Fourier transform of capital X of t, in that case, what we have to do? It is 2 pi times small x of minus omega. The same is being applied here. I got the answer as 2 pi f of minus omega. So the same question appeared in in ISRO 2010. Students, from 15th of June onwards, you will be having Trickopedia. Let's trick it. So, students, on this theme, you will be getting the various tricks from various different subjects. Yes, and that will be on the daily basis. And there is a chance of winning scholarship. You can attend the scholarship test on 11th of June, 12 noon. You can avail scholarships up to 90%. Just note down this, book your calendar, inform this to your juniors. 11th of June, 12 noon. Now, students, determine the discrete time Fourier transform of the sequence. So, we have y of n equal to n plus 1 alpha raised to n u of n. Students, see here. If you are having alpha raised to n u of n, then its dTft is 1 upon 1 minus alpha e raised to minus j omega. This is the first formula. Now, if you are multiplying this by n, then on the other side you need to consider the differentiation. It is minus n d by d omega of the previous result, and previous result is 1 upon 1 minus alpha e raised to minus j omega. Not minus n, minus j. So minus j, yes, differentiation of 1 upon bracket will be minus 1 upon brackets square. So bracket contains 1 minus alpha e raised to minus j omega, and further derivative of this bracket. So minus alpha as it is, e raised to minus j omega will be e raised to minus j omega, and further we have minus omega, sorry, minus j. So what you are getting? Minus j, and this minus j plus j square will be minus 1. When you are multiplying by n here, it is plus j. So differentiation will be minus 1 upon denominator square. And here you will get minus alpha e raised to minus j omega. Yes, and then we have minus j. Correct? Understood this? So ultimately, what will be the result? Result will be j square is minus 1, minus minus plus, and once again plus. So alpha e raised to minus j omega divided by 1 minus alpha e raised to minus j omega whole square. Now, if you replace n by n plus 1, if you replace n by n plus 1, then this will become, or else we would have done something else. What we would have done? It is n plus 1 alpha raised to n u of n, right? Yeah. N is replaced by n plus 1. So u of n plus 1. On the right hand side, what will be the impact? It will be multiplied by e raised to j omega. So you will get alpha 1 minus alpha e raised to minus j omega whole square. So we are getting an extra alpha here. So divide by alpha both sides. You will get 1 upon 1 minus alpha e raised to minus j omega whole square. So 1 upon 1 minus alpha e raised to minus j omega whole square. Option A will be the correct answer. Good evening, Ashok. Yes, not exactly PYQ. The important questions for your upcoming ISRO exam. Now find the energy of the signal sine AT upon pi t. So students, sine AT upon pi t. For this signal, the Fourier transform is rate of omega upon twice a. Correct? This is omega axis. This is x of omega. Rect of omega by twice a. It means from minus a to plus a, amplitude is 1. Now energy of this signal E of x is 1 by 2 pi minus infinity to infinity x of omega modulus square d omega. Correct? So students, 1 by 2 pi minus a to plus a, integration of 1 square, that is 1. So ultimately it is 1 by 2 pi, a plus a will be twice a, it is a by pi joules. A by pi joules. Ashok, it is a by pi joules. Can I have your response, students? See here. Convolution of x of t plus 5 with impulse function delta t minus 7. Convolution, huh? It's not multiplication. So x of t plus 5 convolution with delta t minus 7. So students, result will be this adjacent signal x of t with a net shifting plus 5 minus 7. So ultimately this will be x of t minus 2. X of t minus 2. Option A will be the correct answer. Next, autocorrelation function of x of t. Now students, autocorrelation function of x of t, it is denoted by say r of tau. So r of tau is x of tau convolution with x of minus tau. Correct? If I take Fourier transform both sides, So its Fourier transform will be x of omega multiplied by x of minus omega. Now, Fourier transform of e raised to minus 3t u of t, it is 1 upon 3 plus j omega multiplied by 1 upon 3 minus j omega. So it is 1 upon a square plus omega square. So students, r of tau will be Fourier inverse of 1 upon 3 square plus omega square. If I multiply and divide by 6, then I will get 2 into 3 upon 3 square plus omega square. Now all my dear students, Fourier inverse Fourier transform of twice a upon a square plus omega square, it is e raised to minus a mod of tau. So this is the autocorrelation function of x of t. All fine. Now, students, please see here. By definition of Fourier transform, all my dear students, ensure to hit the like button. Fourier transform of x of t is x of omega. It is minus infinity to infinity x of t e raised to minus j omega t dt. So if you put omega equal to 0, you will get capital X of 0 minus infinity to infinity x of t dt. It means area under signal x of t, area under signal x of t is x of 0, correct? So what we want? We want capital X of 0. It is area under this signal x of t. So x of 0 is. So I will be calculating the area of this entire rectangle. Base is 4 unit, height is 2 unit. Minus area of this triangle. Minus area of this triangle. So this will be half this base. This base is 2 units and this height is 1 unit. So 8 minus 1, that is 7. So answer for this is 7. Now minus infinity to infinity x of omega d omega. It means this can be achieved with the definition of inverse Fourier transform. By inverse Fourier transform, x of t will be 1 by 2 pi minus infinity to infinity capital X of omega e raised to j omega t d omega, correct? If I put if I put t equal to 0 both sides, so x of 0, 2 pi is cross multiplied here. So I am getting the integration minus infinity to infinity capital X of omega d omega, correct? So 2 pi x of 0, 2 pi x of 0 is the value of this integral. Now x of 0 is x of 0. The value of signal x of t at t equal to 0 is 2. At t equal to 0, x of t is 2. So 2 into 2 pi will be 4 pi. This is the answer. Please go through it. Hello. I think I'm audible now. So 2 by 3, omega will be replaced by 2 pi f. So minus j 4 pi f. X of, in this bracket, omega will be directly replaced by f. So 2 by 3 e raised to minus j 4 pi f. 2 by 3 e raised to minus j 4 by f and x of minus f by 3. So I guess option C is the correct one. Now this question is based on the Nyquist rate. If the Nyquist rate of the signal x of t is 500 hertz, see here, x of t is having Fourier transform x of omega. Now x of 5t by time scaling property, it is 1 by 5 x of omega by 5. Now students, it means x of omega is expanded by 5 times. So when x of omega is expanded by 5 times, the Nyquist rate will also be expanded by 5 times. So 500 into 5, new Nyquist rate will be 5 times the old Nyquist rate, that is 2.5 kilohertz. Priya, somewhere around the month of June, in the mid of July, it can be expected. The frequency response of a system. So h of omega is given. Find out its phase angle. Theta omega will be, since it is in denominator, it is minus tan inverse omega by 1. Okay. Now what we want? We want group delay and phase delay. Students, group delay is Tg. Its formula is minus theta omega upon omega. So this is ultimately tan inverse omega. This is actually phase delay, Tp. So tan inverse omega upon omega. Yeah. And the group delay is Tg. It is minus d by d omega of theta omega. So this minus and this minus will be plus d by d omega tan inverse omega. So it is 1 upon 1 plus omega square. So Tg is 1 upon 1 plus omega square. They are asking for group delay first. Group delay is 1 upon 1 plus omega square. And then we have phase delay, tan inverse omega by omega. Option B is the correct answer. Sequence is also important. Now see here. This question can be targeted through the Laplace transform. A continuous time LTI system is described by this equation. Assuming zero initial conditions, the response y of t of the system, x of t is given. Okay. What is x of t? E raised to minus 2t u of t. Its Laplace transform is x of x. So x of s will be 1 upon s plus 2, correct? Now, let us write this equation in the form of dashes. So double derivative can be written as y double dash t. Four times y dash t three times y of t equal to 2 times x dash t plus 4x of t. Now, in this equation, I will be taking the Laplace transform. So, Laplace of y double dash t will be s square y of s if the initial conditions are set to 0. Similarly, it is Laplace of y dash t will be s y of s, and Laplace of y of t will be y of s. Laplace of x dash t will be s x of s, and it is 4 times x of s. So I am taking this y of s common. From here I am taking 2 common, x of s common, so 2s plus 2 into x of s. Now what we need? We need the response of the above system for this input. Okay. So let us put x of s. What is x of s? X of s is 1 upon s plus 2. So s plus 2 gets cancelled. So y of s will be 2 times 2 upon s square plus 4s plus 3. I am just factorizing the denominator, s plus 1, s plus 3. Do the partial fractions. 1 upon s plus 1 minus 1 upon s plus 3. S and s gets cancelled. 3 minus 1 will be 2. Taking Laplace inverse, you will get y of t. It is e raised to minus t, and this is e raised to minus 3t. Let us assume both of them to be right sided. So it is u of t. Option B is the correct one. Ensure hitting the like button. Now see here. A system is described by the differential equation. They have given you a differential equation. Let x of t be a rectangular pulse. Now students, x of t is given as 1 and 0. 1 in the interval 0 less than t less than 2, and otherwise it is 0. Okay, so this x of t can be written as u of t minus u of t minus 2. And if you take the Laplace transform, it is x of s, u of t's Laplace is 1 by s minus e raised to minus 2s by s. So it is e raised to minus 2s upon s. Okay. Now, again in this question also initial conditions are all set to 0. Now students, can we write this differential equation in the form of dashes? So d square y by dt square y double dash t, 5 times dy by dt means 5 y dash t, six times y of t and on the right hand side we have x of t. Taking Laplace transform both sides. Now we are taking y of s common from the left hand side. And on the right hand side we have x of s. So what we want? We want Laplace transform of y of t. We want Laplace of y of t means y of s. X of s upon s square plus 5s plus 6. So y of s means Laplace of y of t. And x of s just now recently we obtained 1 minus e raised to minus 2s by s. And already we have two more factors in the denominator. So this is our answer. 1 minus e raised to minus 2s, s plus 2, s plus 3. Yes, find out. Option B is the correct answer. Next. No. Solving this equation means finding out y of t. So taking Laplace both sides. So y of s. Okay, before that, this integration is nothing but convolution between y of t and x of t. Now taking Laplace transform both sides. So Laplace of y of t is y of s. And here, when you take the Laplace transform, it is y of s into x of s. Here Laplace of x of t is x of s. Laplace of impulse function is 1. Delta t, Laplace is 1. On the left hand side, I am taking x of s common. So 1 plus x of s. And once again 1 plus x of s. So these two brackets will cancel each other and you will get y of s equal to 1. So y of s equal to 1 means y of t is inverse Laplace of 1. So inverse Laplace of 1 means delta t. So this is the solution for this equation. Correct? Come on, respond. देख लीजिए. Now see this signal. We need to find out the average value of the periodic signal x of t. So this signal is periodic with a period of 6. So average value a naught. This is 1 by t. Area under x of t in one period. So 1 by t, t is nothing but 6. And area under x of t in one period. So what you need to do? You need to calculate this area of this small triangle, then area of this rectangle and this rectangle. Yeah. So area of this small triangle, half base into height. Then area of this rectangle or square, whatever. This is, so base is 1 unit, height is 1 unit. and the area of this third rectangle. 1 is the base and 3 is the height. So we are getting 5 by 6 is the answer, average value. A periodic rectangular signal x of t has waveform shown in figure. Okay, so find out the period. Period is 4 milliseconds. So fundamental frequency is 1 by t, 1 by 4 kilohertz. 1 upon milli means kilo. So it is 250 hertz. Try to be focused. You can avoid silly mistakes by focusing on the current task, not thinking of anything else. So this is the frequency of the fundamental frequency. So frequency of the fifth harmonic will be 5f0. So 250 into 5 will be 1250 hertz. Akansha Vashisht. Yes, beta, perfect. Now, every one of you can read out this question and try to answer this. Do I need to hide myself? See here. Statement S1, deterministic signals can't be predicted. Deterministic signals are the predicted signals, so S1 is wrong. Random signals can be expressed using mathematical expression, that is also wrong. Random signals can be analyzed using probability and statistical measures. Yes. So, which of the following statements? Statement S1 is false. Yes. Statement S2 is true. This is wrong. Statement S3 is true. This is true. Statement S1 is true. That is wrong. So A and C are the correct ones. Yeah. Just a thinking based question. Simple question. Just go through this. The Fourier transform of a function is equal to its two-sided Laplace transform. Students, you can obtain Fourier transform result from the Laplace transform result only when the signal is absolutely integrable. If the signal is not absolutely integrable, you cannot obtain Fourier transform result from the Laplace transform result. Are you getting my point? Generally, what happens in case of Laplace transform result, if you substitute s equal to j omega, you will get the Fourier transform result. But that is only possible when the signal is absolutely integrable. Signal is absolutely integrable means ROC covers j omega axis. So on the real axis, no. J omega axis is the imaginary axis. On the imaginary axis of the S-plane, this is correct. Option C is the correct. Option C is the correct one. Sri Sweta, correct. Akansha, correct yourself. In Laplace transform result, if you put S equal to J omega, you will get Fourier transform result. But this is possible only for absolutely integrable signals. Absolutely integrable signal means ROC covers imaginary axis. ROC covers J omega axis. So option C is the correct one. Now, which one of the following is the correct relation? So they're talking about the time scaling property. So Fourier transform of f of a t is 1 upon a f of omega by a. Option D is the correct one. One liner question. If the Fourier transform of x of t is 2 by omega, sine pi omega, then if you are multiplying x of t by e raised to j 5t, then what happens? 2 upon omega will become omega minus 5. So 2 upon omega minus 5 sine pi of omega minus 5. Option D is the correct one. Can I have your response? C. Yes. So G of omega will be omega square plus 21 upon omega square plus 9. Some basic maths is required here. I am just writing 12 plus omega square plus 9 upon omega square plus 9. So it is 1 omega square plus 9 upon omega square plus 9 is 1 plus 12 upon omega square plus 9. Now see here, little bit more adjustment. 12, it is 2 into 6. 9 can be written as 3 square plus omega square. Taking inverse Fourier. So inverse Fourier of 1, 2 is out. Inverse Fourier of 2a upon a square plus omega square. So inverse Fourier of g omega is g of t. Inverse Fourier transform of 1. See, Fourier transform of delta t is 1. So inverse Fourier of 1 will be delta t. Then Fourier inverse of twice a upon a square plus omega square, it is e raised to minus a mod of t. Correct? Shabash, Shweta. Wishing you all the best for your upcoming exam. Students, I will be coming live with engineering mathematics classes on YouTube in the next week. Something around 15th of June. Yeah. So I will update you. Thank you so much for being with me. And if you have not yet subscribed this channel, I request all of you to subscribe this channel. Hit the like button if you have not done so. And students, share the link of this session in all your friends, among all your groups, so that a large number of needy students can get the help from this beautiful channel. So students, we help you in growing you in your career, and you should help us in the form of number of students. Love you all. Take care. Stay happy. Stay safe. Jai Hind. Jai Bharat. Just take care of yourself. Take care of your parents as well. Thank you.